Okay, hello students, and welcome to today's Friday Math Happy Hour. Today we're going to be covering law of sines and law of cosines. This is sections 6.1 and 6.2 from the 2412 book. Okay, these are the main objectives that I'm going to cover. Use the law of sines to solve oblique triangles, which is AAS means angle, angle, side, or angle, side, angle, and side, side, angle. And find the areas of the oblique triangles. Use the law of sines to model and solve real-life problems. Use the law of cosines to solve oblique triangles, side, 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 or side, angle, side. Use the law of cosines to model and solve real-life problems. And use Heron's area formula to find areas of triangles. Okay, now this is a rules for the formula for law of sines. If they give you two triangles, right? This is an acute triangle because A is acute, angle is acute, it's less than 90 degrees. And on the right side, A is obtuse because A is more than 90 degrees. Okay, this is important, guys, because there can be one triangle, two triangles, or no solution. We're going to be using A sine of A, little a sine of A, and equals to little b sine of B, and little c over sine of C. The little a means it's going to be the side. For example, here, A is the side, right, which is opposite from the angle A. Okay. Okay, now to use a formula, you must have a pair of like, for example, angle A with little a, or the side A, or angle B with little b, or angle C with little c, side C, right? That's you need to have those to use a formula. Again, here it is, right? Okay, now this is easier to solving for a side. In this form. And if you use a reciprocal, this will be easier solving for an angle. Okay, please keep that in mind. Let's do example number 1. It says, given two angles in one side, angle, angle, side. For the triangle in figure 1C, C is equal to 102 degrees, B is equal to 29 degrees, and side B, or little b, is equal to 28 feet. Find the remaining angle and sides. Okay, this is figure 1C. Okay, here's the picture, right? Okay, now we have to find all 6, right? The 3 angles and the 3 sides. Let's first start extracting what's given. They give us angle B is 29 degrees. They also give us angle C is 102 degrees. And they give us little b, side B is 28 feet. Okay, guys, there's our pair, right? So this is we're going to be using the little b with the angle B. Okay, so but we need to find angle A, side A, and side C. So we can start finding angle A, right? Because they give us 2 angles, and the area of a triangle is 180 degrees. So to solve for A, we subtract B and C from both sides. So A equals to 180 minus B minus C. Now let's plug in the values here for the angles. Right, angle B is 29 degrees, and angle C is 102 degrees. So if we subtract 180 minus 29 minus 102, the result is 49 degrees. So angle A is 49 degrees. Up here. Okay, now use a pair of angle B and side B to find sides A and C. So to find A, it's going to be side B over angles over the sine of angle B equals to side A over the sine of angle A. You see, B is 28 feet, angle B is 29 degrees, and angle A is 49 degrees. So now here, guys, right? To solve for A, we're going to multiply both sides by the sine of 49 degrees. If we do that, it's going to give us sine of 49 degrees times 28 divided by sine of 29 degrees. Here, guys, we use a calculator and make sure that the mode is in degrees. So side A is 43.585, but I believe they want us to round off to 2 places. So approximately it'll be like 43.59. So side A will be 43.59. Now let's find side C. So again, since a pair was given, the angle B and side B was given, that's what I'm going to be using. Okay, now just plug in everything. Again, B is 28 feet. The angle B is 29 degrees. We're looking for side C. And the sine of angle C is 102 degrees. Again, here we're going to multiply both sides by the sine of 102 degrees. This will give us sine 102 degrees times 28 divided by the sine of 29 degrees. Again, make sure that your calculator is in the degree mode. This is going to give us something like 56.492. Round it off to the 2 places will give us 56.49. So this is my result for side C, 56.49 feet. Okay, now let's do another example. This is from the homework. It says, use a law of sines to solve the triangle. Round your answers to 2 decimal places. Okay, let's start right by what's given. They give us angle B is 10 degrees. Angle C is 135 degrees. Side A is not given, nor B. Side C is given 45. So C is 45. Now, the first thing we can find, guys, is angle A, because they give us 2 angles, right? So we can use the formula that angle A plus angle B plus angle C must equal to 180. So we're looking for, or trying to find for angle A, we subtract B and C from both sides. So it's going to give us angle A is equal to 180 degrees minus B minus C. We know that B is 10 degrees. We know that C is 135 degrees. So angle A will be 35 degrees. So angle A is 35 degrees. So we found angle A. Okay, now they also give us a pair, right? They gave us angle C and side C. So that's the pair that I'm going to be using. Okay, so to solve for A, I'm going to be using side C over the sine of angle C equals to side A over the sine of angle A. Right, let's plug everything in. Here, guys, we're going to multiply both sides by sine of 35 degrees. So it's going to give us sine of 35 degrees times 45 over sine of 135. Right? And again, make sure that your mode and your calculator is in degrees. So the result is 36.502. Round it off to 2 places will give us 36.50. So that's side A. Now to solve for side B, again we use a pair that was given from the start, which is angle C and little c. Just plug everything in, right? My C is 45. My angle C is 135. We're looking for side B. And my angle B is 10 degrees. So it'll be sine of 10 degrees. So here, guys, we multiply both sides by sine of 10 degrees. It's going to give us sine of 10 degrees times 45 over sine of 135 degrees. Use your calculator. So it's going to give us something like 11.050. So the answer will be 11.05. That's the result for side B. Okay, now, this is how you do it in real life. It says a pole tilts towards the sun of an 8-degree angle from the vertical, and it casts a 22-foot shadow. See figure 6.2. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? Okay, here's the figure 6.2. Again, guys, the pole tilts towards the sun, right? So you see, if you notice, the pole tilts towards the left at an 8-degree angle. And the shadow that it casts is 22 feet. So this is a shadow, 22 feet. Okay, the angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So this is 43 degrees. Okay, now, let's see. Let's see what's given. Okay, angle A, no, let's see, that's B. Angle A is 43 degrees. Hey guys, angle B is also given, right? Because angle B, this angle here, guys, okay, one more thing I forgot. I mean, little c is also 22 feet. And we're looking for little a. Okay, now, angle B, right, if you notice, it's 90 degrees, right? Because if it's vertical or perpendicular to the floor, is 90 degrees plus the 8 degrees that tilts. So angle B is 98 degrees. Okay, now, if we notice, guys, we need to find a pair, right? But we don't have the pair yet. So once we find angle C, we found a pair that we can use for the formula, which is side C with the angle C. So we're going to find angle C first. Right, so we're looking for angle C, so we subtract angle A and angle B to both sides. So angle C is equal to 180 minus angle A minus angle B. Angle A is 43 degrees, and angle B is 98 degrees. So C equals to 39 degrees. So I got my C, 39 degrees. Okay, now I got that pair, right? And we're looking for little a, right? Because, or little a is the same thing as side A, which is the height of the pole. So, right, so we're going to use the proportion of little c over sine of c equals to little a over sine of a. Let's plug in what we have. C is 22 degrees, 22 feet. The sine of angle C is 39 degrees. We're looking for little a, which is the height of the pole. And angle A is 43 degrees, so over sine of 43 degrees. We multiply both sides by sine of 43 degrees. It's going to give us sine of 43 degrees times 22 over sine of 39 degrees. So it's going to be 23.8415. I think we should round out to two places. So it's going to be 23.84. So the height of the pole is 23.84 feet. That's how we find the height of the pole. Okay, now, hey guys, this is like the main concept for this section, okay? Even though we did like 3 examples, but this is what you need to look at. You have to compare, right, the A with the H and the A with the B. Side A with the height and side A with side B. And here it tells you how many triangles there's going to be. For example, if angle A is acute, there's 4 possibilities, right? This is the first one, which is none. If A is less than H, it's 1 if A equals to H. It's also 1 if A is more than or equal to B. And if A is between H and B, it's going to be 2 triangles. And if it's obtuse, it's going to be none. If A is less than or equal to B, it's none. And it's going to be 1 if A is more than B. And H, right, like I said here, you need to compare A with H and A with B to determine the number of possible triangles. And H equals to B sine of A. So to find H, we have to have B, side B, and the sine of angle A. Okay, so let's start. It says here, for the triangle in figure 6.3, A equals to 22 inches, B equals to 12 inches, and angle A equals to 42 inches. Find the remaining side and angles. Okay. There's figure 6.3. Here, guys, right here it's saying that A is more than B, right? Because A is 22 and B is 12, right? So if you look at the slide, at the previous slide, right? It's acute and A is more than B, so it's going to be exactly 1 triangle. So we can solve it as we did the other, the other examples that we did. So let's have write down what's given. Let's see, angle A is 42 degrees. Side A is 22 inches. And side B is 12 inches. Okay. So here, right, they give us a pair, right? So let's do this. Need to find angle B and angle C and little c. So first, we can find angle B. How? Because they give us a pair, the angle A and little a, so we can solve, and they give us B, so we can solve for angle B. Remember, guys, if we're looking for angles, we use a reciprocal of what we've been using. So instead of using sine A over sine of A equals to B over sine B, we're going to use sine of A over A equals to sine B over B. This will be easier, and you're going to know right now when we work the math out how it's easier. It's less work. Okay. So we have sine of 42 degrees because A is 42 over 22 inches equal to sine of B over 12 inches. We're looking for sine of B, and we're looking for angle B. So here we multiply both sides by 12. So it's going to give us 12 sine of 42 degrees over 22 inches. So here, guys, right here, we're going to take the arc sine because we want to solve for B. So to cancel the sine on the right side, we take the arc sine or the inverse. Right, we take the arc sine on both sides, so it cancels on the right side. So arc sine of 12 parentheses sine of 42 degrees over 22 close parentheses is equal to B. So when you put it into the calculator, guys, you're going to put inverse sine, which is the arc sine, and then you're going to put parentheses. Then you're going to put 12, open another parentheses, sine of 42 degrees divided by 22, divided by 22, close parentheses, and close it again. And it's going to give you something like 21.406 degrees. I believe I want you to round off to 2 places, so B equals to 21.41 degrees. Now we have 2 angles, right? So we can solve the third angle, angle C, by using the A plus B plus C equals to 180. So if we're looking for angle C, we subtract AB from both sides. So it's going to give us 180 minus A minus B. So now we plug in the angles for A, which is 42, and the angle for B, which is 21.41. We use the calculator. It's going to give us 116.59 degrees. So that's my angle C. Okay, now to solve for side C, right, we can use the original, the sine of angle A over A equals to sine of angle B over B, right? But it's going to be equals to sine of angle C over little c. Now, you know what, guys? Here, no, we're looking for the side, so we're going to use the one that we use, the reciprocal of this one here. My bad, guys, we're going to be using this one here because it'll be easier. Okay, again, remember, guys, when we look for angles, we use the sine of A over little a equals to sine of B over little b. But if we're looking for the sides, we use A over sine of A equals to C over sine of C because the work is easier. Now let's plug everything in. Side A is 22 inches. Angle A is 42 degrees, so it'll be sine of 42 degrees. We're solving for side C. And the angle of angle C is 116.59, so it's going to be sine of 116.59. We multiply both sides by sine of 116.59. The result will give us the sine of 116.59 degrees times 22 divided by sine of 42 degrees. Put into the calculator, it's going to give us something like 29.401. So it's going to be 29.40. So we found angle C, and we found everything that we needed for this problem here. Okay, now, hey guys, this case, example 4, is one with no solution, okay? But here's why. Okay, they give us angle A is 85 degrees. Side A is 15, and side B is 25. Okay, now, we know it's going to be A is an acute angle, right? Acute. So then we're going to compare the A, the B, and the H. Okay, compare it with B and A with H. Right, so it's going to be one of these here, guys. right away we know that B is more than A, right? So right away we know that this one cannot be it, where it says 1, right? Because on this one, A is more than or equal to B, which is not true here. So now I need to find my H. Once I find my H, we know exactly which one it is. If it's going to be none, or no solution, or one triangle, or two triangles. Okay. So H is equal to B over B times sine of A. So B is 25. A is 85 degrees. So it'll be 25 times sine of 85 degrees. H equals to 24.904. If you notice, let's see here. So we know that it cannot be that one, right? With 1. If you notice, A is 15 and H is 24.904, which means it's going to be the first one. No solution, because A is smaller than H. So for this one, no solution. Hey guys, so my advice to you guys, because this one, I mean, for this one you can do all the work, and at the end, it's not going to be possible. So instead of doing all the work, first compare the A, the B, and the H, and this way you can know exactly how many triangles it's going to be. Because if it's none, you're doing work for nothing, right? If it's 1, well then you do what we've been doing, right? But this is the main thing, like I said on the slide that showed all the rules here. That's the main thing you got to know. So always do that first. This way you don't do as many as much work, because you know exactly which one's going to be. Okay, now again, this is from the homework. Use the law of sines to solve, if possible, a triangle. If 2 solutions exist, find both. Run your answer to 2 decimal places. Okay, so let's write everything that's given. The given angle A is 110. Side A is 125. And side B is 200. Okay, now guys, by the way, we should know that A is obtuse, right? So we're going to use the obtuse, right? A is obtuse, compare A with B, right? Because A is more than 90 degrees, it's obtuse, so it's going to be one of these two. It's going to be either no triangles, or no solution, or 1 triangle. We notice we compare A with B, right? So A is less than or equal to B, because A is 25 and B is 200. So right away we know it's going to be no solution without doing no work at all. Okay. Now this is an example when you have 2 solutions. Okay. Okay, two solutions again. So let's work it out as normal, as we've been doing. But we know that A is 20.5, so we know it's going to be acute, right? It's an acute angle, angle A. A is 12 meters, and B is 31 meters. Okay, so let's compare A with B and A with H. You see which one it is, guys. Here it's saying that B is more than A, right? So B is more than A, so right away we know this one cannot be it here. I mean, we know this one cannot be it. It cannot be 1, because on 1, A is more than B. But to see which one it is from, we also need to find H. So H is equal to 31 to B, 31 times sine of A, which is 20.5. H is equal to 10.859. If you notice, let's see here. Let's go. First of all, right? A is not more than B, so that cannot be it. Here it's saying that H is more than A. Is that true? No, right? A is 12 and H is 10.859, so A cannot be none. A equals to H. We see A equals to H. That's not true, because H is equal to 10.856 and A is equal to 12, so that's not it. So if you notice, guys, A is between H and B, right? Because H is 10.856, A is 12, and B is 31, so it's going to be two triangles. So for 2 triangles, we need to find angle B, angle C, and little c. So let's start, right, because it gives us a pair, they give us angle A and side A, so we're going to use that one, right, but we're looking for angle B, so we're going to use the reciprocal of the original formula. So I'm going to plug everything in. Sine of 20.5 degrees over 12 equal to sine of B over 31. Multiply both sides by 31. So on the left side, we have 31 times sine of 20.5 degrees divided by 12. Now, here, guys, to solve for angle B, we're gonna take the arc sine of both sides, right? So the arc sine cancels the sine on the right side. On the left side, we have the arc sine of 31 times the sine of 20.5 degrees over 12. So you put that into the calculator, guys, it's going to give us 64.783. I call it B1 because because we're going to have two triangles. Because when you have two triangles, the A's are the same, right? And also the side B, but the rest of the info, B, C, and little c, will be different for both triangles. So for triangle number one, right, we know that B is equal to 64.78. Now I need to find C. So as we use A plus B plus C equals to 180. So C equals to 180 minus A minus B. Let's plug in the values for the angles. So C equals to 180 degrees minus 20.5 degrees minus 64.78 degrees. So C equals to 94.72 degrees. Okay, now to solve for side C, right, we use a reciprocal of what we use for the angle, right? So it's going to be A over sine of A equals to C over sine of C. Let's plug in the values. My A is 12. My angle A is 20.5, so it's going to be over sine of 20.5. We're looking for side C, or little c, and angle C is 94.72. So here, guys, we're going to multiply both sides by sine of 94.72. So it's going to give us sine of 94.72 degrees times 12 over sine of 20.5 degrees. Let's use a calculator, and again, make sure that it's in the mode is in degrees. So C approximately is 34.149. Rounded up to two places will give us 34.15. So side C is 34.15. Okay, guys, this is the first triangle. Now, where do we find the second triangle? Right? So we're going to go to B here, guys, right? So for the second triangle, we subtract angle B minus 180, and that'll be my second one. So B2 is equal to 180 minus 64.78. So B2 is equal to 115.22. Now let's go to the next slide. That way we can solve for the second triangle. Okay, so now, guys, right? So B2 was 115.22. Right? This was everything for the first triangle that we just solved. Now we got the second one. Let's extract all the info. A is 20.5. B is 115.22. Okay, let me show you. Right? A is 12 and B is 31. So now, right, to solve for angle C, angle C is equal to 180 minus angle A minus angle B. Let's plug in the values for angle A and B. Right, so C equals to 44.28. So that's my angle C. Now to solve for side C, right, we use the combo A over sine of A equals to C over sine of C. A is 12, and angle A is 20.5, so it'll be 12 over sine of 20.5. And angle C is 44.28, so it's going to be C over sine of 44.28. We multiply both sides by sine of 44.28. So it's going to give us sine of 44.28 times 12 over sine of 20.5 equals to side C. Put into the calculator. It's going to give us something like 23.922. Rounded out to two places, it will be 23.92. So I solve my second triangle. I got both triangles. Okay, now we're going to find the area of an oblique triangle. Okay, just here, the area of any triangle is 1/2 the product of the length of the two sides times the sine of their included angle. That is, the area is equal to 1/2 side B and C times sine of A, angle A, or 1/2 AB times sine of angle C, or 1/2 AC times sine of angle B. Okay. Example 6. Finding the area of a triangular lot. Since you find the area of a triangular lot with two sides of 90 meters and 52 meters, and the included angle is 102 degrees. Okay, that's like a picture of it. There's my, we can call this, since this is first, I call this side A, which is 90 meters. The 52 will be side B, 52 meters, and the angle is 102. So you notice which formula we're going to use from here, right? Because here are three different formulas. So they give us, so we're looking for, let's see here. We're looking for the area, so they give us little b, and they give us side A and B. So it's going to be this one here, right? It's going to be the one in the middle because they give us angle C and they give us side A and B. So let's plug everything in, right? My A is 90, my B is 52, and my C, angle C is 102. Use your calculator. So the area here, let's run down to a nearest meter. It's going to be 2,289. Hey guys, I mean meters, right? But it's supposed to be square meters. Let me go back. I forgot to put meters squared or square meters, right? Because the area is always in square meters. So the answer should be 2,289 meters squared or square meters. Okay, I'll fix that later. Now, it says here, find the area of the triangle. Round your answer to one decimal place. Okay. So, hey guys, so 42 says angle B is 54 degrees, and 30, guys, the little thing on top, guys, means minutes. If it was two of them, it means seconds. Okay, here it is. 1 minute is equal to 1/60 times 1 degrees is 1 minute. If it's one, right, like double prime is equal to, this means seconds, will be 1/3600 times 1 degrees is 1 second. So first, guys, I need to convert the 30 minutes into degrees. Okay, so 54 degrees and 30 minutes is equal to 54 degrees plus 30 over 60, right? Because that's a conversion, 30 over 60 degrees. 30 over 60 is 0.5. So 54 degrees and 30 minutes is equal to 54.5 degrees. So now I have my I have angle B, and they give us little A and little C, right? So we're going to be using this formula here because they give us side A and side C, and angle B is the one that we're going to be using. Let's plug everything in. A is 62 degrees. C is 35. I mean not 62 degrees, just 62. Let's see. C is 35, and angle B is with a sine of 54.5 degrees. Use your calculator. The area will be like 883.315. Round it off to one place will give us 883.3. And again, let me go back. I keep forgetting to put square, right? So this just be square units because they don't give you the units. It'll just be square units or unit square. Okay, now guys, we're done with 6.1. Now comes 6.2. This is the law of cosines. Okay. This is a standard form, right? Like for example, to solve for say side A is equal to A squared equals to B squared plus C squared minus 2BC over cosine of A. Guys, if you notice the pattern, right? If we're looking for side A, right? All the sides are going to be B and C, but the cosine, but the angle will be A. Same thing here with B, right? For example, if we're looking for side B, we have side A and side C, and So we're looking for side B, it's going to be cosine of B. And same thing with C squared is equal to A squared plus B squared minus 2AB times cosine of C. Now this is the formula if you're looking for the side. But if you're looking for the angle, this is what you use. Because if you solve this formula for the angle, this is what you will get. Cosine of angle A equals to B squared plus C squared minus A squared over 2BC. And if you're looking for B, for angle B, right, it's going to be cosine of B equals to A squared plus C squared minus B squared over 2AC. And finally, the cosine of C equals to A squared plus B squared minus C squared over 2AB. Now, I'm gonna rewrite them, each one of these, for it to be easier to put into the calculator. Okay? Right, this is to find a side, and over here is to find an angle. Okay, now, because what's easier, guys, this way you can put everything in the calculator, guys, just the way it is, right? So the first one here, right, if we take the square root of both sides, it's going to give us A equals to the square root of B squared plus C squared minus 2BC cosine of A. Same thing with the second one, which is B, and same thing with C. So it's better to use these because these, they're ready to put into the calculator. That's one less step than doing it this way over here on top. Same thing for the alternative form for finding for the angles, right? So here, guys, is going to be the arcsine or the inverse, right? So to solve, so A equals to the inverse cosine or the arcsine of B squared plus C squared minus A squared over 2BC. Same thing with angle B and same thing with angle C. So these are the ones that I'm going to be using. Okay, the simplified version ready for you guys to plug into the calculator. Okay, now, example. They give us here three sides. Find the three angles of the triangle shown below. So A is 8 feet, B is 19 feet, and C is 14 feet. Because if you notice, why do we use the law of cosines? Because there's no way I can get a pair. You see, guys, to use the law of sines, you have to have a pair, like the angle A with side A, or angle B with side B, or angle C with side C. And here, guys, it's impossible because they don't give us an angle. That's why we have to use the law of cosines. And if you want, you can continue using everything with law of cosines, or once you find an angle, which will give you the pair, we can go back and use the law of sines. It's up to you. So you can use, right? So first, okay, let's solve for angle A. So again, this is the formula that I got from the previous slide. So angle A is equal to the arc cosine of B squared plus C squared minus A squared over 2BC. So let's plug in the values. My B is 19, so it'll be 19 squared, plus C is 14, plus 14 squared, and my A is 8, so it'll be minus 8 squared, over 2 times B is 19 and C is 14. You can just plug it into the calculator how it is. So it's going to give you approximately 22.075. So round it off to two places, it's going to be 22.08 degrees. That will be angle A. Now, if I want to, right, but I'm going to continue with the same formula because this is not that hard, right? Because after you got the formula, all you do is plug in the values and use the calculator. So I'm going to stick to this instead of using the law of sines. So again, my A is 8, so it'll be 8 squared. My C is 14, so it'll be plus 14 squared, minus my B is 19 minus 19 squared, over 2 times 8, which is A, times 14, which is C. Put into the calculator, guys. It's going to give you that 116.8009. Round it out to two places, 116.8 degrees, or 80 degrees. Now we can find angle C, right? We can, do it the same way, guys, right? But it's easier to use that that angle A plus angle B plus angle C equals to 180. We're looking for angle C. So it's going to be 180 minus angle A minus angle B. Plug in the values for angles A and B. And it gives us angle C is 41.12 degrees. That's my angle C. So I solved the triangle. Okay, now, example 2. Example 2, guys, they give us two sides and one angle. Okay. For example, they give us angle A is 25 degrees. Side B is 9 meters. and side C is 12 meters. Okay. So here, guys, we're going to use the first. Let's solve for angle A, I mean for side A, and then we'll find angles B and C. So side A is equal to the square root of B squared plus C squared minus 2BC times cosine of A. Again, these are the formulas that were in those formulas that I told you at the beginning of 6.2. Plug everything in. Use your calculator. You can get something like A is equal to like 5.40717. Guys, here, guys, I got this example from the book. Okay, I don't know why they kept it with 4 places, so I just kept it the same way with 4. It doesn't give you any instructions, but because I think the more that you run that off, if like on web assign in your homework, there will be a chance for you to get it wrong because web assign is real strict, right? When you round off, and so maybe that's the reason that they keep it like this. Okay, so A is 5.4072 meters. Okay, now let's go back right to the angles again, right? Let's see what's up here. Right, angle A is acute, right, because it's less than 90 degrees. Now we know that B is 9 and A is 5, right? So B is more than A. So right away, right? Let's see which one can be it. But let's find H first, and then we can see which one it is. H equals to B, which is 9 times sine of 25 degrees. H is equal to 3.8035. So you notice it cannot be this one. No, because A is not less than H. A is more than H. It cannot be the first one. H does not equal H. It cannot be the second one. So it's going to be also 2 triangles. Okay, so it's going to be 2 triangles. So let's put out the info, guys, right? Triangle 1 and triangle 2. So we need to solve for angle B, and from there is where the 2 triangles come out. But I believe, guys, the question was let's go back real quick. They were looking to find the remaining angles, right? So we're looking for 2 angles and the side. We know that the side is 5.4072, right? So we're looking for 2 angles, only angles B and angle C. Okay, now, so for triangle number 1, we're going to use the law of sines, right? Because it gave us an angle with a pair. They give us angle A and little a. And here we're going to be looking for angle B. So it'll be sine of 25 degrees, or 5.4072 equals to sine of B over 9. Multiply both sides by 9. It's going to give us 9 times sine of 25 degrees over 5.4072 equals to sine of B. So we take the arc sine of both sides, the arc sine. So enter into the calculator. It's going to give us 44.7025 degrees. So this is the angle B1, right? Here, guys, they actually rounded off. And again, I'm copying the same example from the book. I think for the angles, I think here they go 4 places because they'll be more accurate. Okay? So then we can find for triangle number 1, right? We can find angle C. But remember, guys, I told you that from angle B is where the other triangle comes in. For B2 is going to be 180 minus angle B. Angle B1. So it's going to give us B2 will be 135.3. So now I have the triangle for angle 1, right? So now we're missing angle C. So on triangle 1, we're going to use the A plus B plus C equals to 180. So C equals to 180 minus A minus B. So it's going to be 180 minus 25 degrees minus 44.70. So angle C will give us 110. So it'll be 110.3 degrees. Now for triangle 2, right? We use the same method as for triangle number 1. So angle C is equal to 180 minus angle A minus angle B. Plug in the values. So angle C is equal to 19.7. Okay, now, you notice, guys, we also have to find little c, but they weren't asking for that. Okay, so we just scratch it off, guys, right? So which one are they looking for? Here, guys, since side C, guys, is the biggest, you know what, guys, that shouldn't be there, guys. That right there, okay? I think I was copying and pasted, so I made a mistake. So just disregard that C equals to 11.05, 55.05. Since side C is the longest side of the triangle, which means that the angle C is the largest angle of the triangle. So we go by the largest angle. So the answer will be 110.3 degrees, and B is 44.7. So this is the one that we go by. Right, so the answer will be A is equal to 5.4, maybe 41, right? Because now we run that out back, 5.41, and angle B will be 44.70, and angle C will be 110.3. Okay, and again, disregard that C approximately equals to 11.05, 505. Okay, that was my mistake there. Okay, now let's do one more. Use the law of cosines to solve the triangle. Round your answer to two places. Okay, let's see what's given. They give us angle C is 105, side A is 9, and side B is 4.5. Okay, from here, guys, let's see. We need to find side C and angles A and B. So how can we find side C, right? By using the law of cosines. Side C is equal to the square root of A squared plus B squared minus 2AB times cosine of C. Let's plug everything in. Okay, so side C will be 11.05, 505. So say 11.06. So we got side C. Okay, now for angle A, right? When we find angle A, then we can see how many triangles it's going to be, because angle A is what determines if it's acute or if it's obtuse. So for angle A, right, we use the cosine formula to find angle A. So it'll be called the inverse cosine times B squared plus C squared minus A squared over 2BC. Plug everything in. So angle A is 51.79, right? Which means angle A is acute, right? Since angle A is acute, and there's four conditions, and one was that the A is more than or equal to B, right? Which it is. A is more than or equal to B, so it's going to be one triangle. So for one triangle, guys, all we have to worry is about finding B, and we're done. So to solve for B is going to be angle A plus angle B plus angle C equals to 180. Right, so B equals to 180 minus angle A minus angle C. So plug in the values for angle A and angle C. So we have 51.79 degrees and 105. Use a calculator, and we get 23.21 degrees. That's my result for angle B. So I solved my triangle. And again, guys, if you notice, I'm always going back to those six conditions. There was 4 for acute, and there were 2 for obtuse. That's what we need to go by to see how many triangles there's going to be. Okay. Now let's use Heron's area for formula. The area I'm using Heron's area formula is given any angle with sides of length A, B, and C. The area of the triangle is equal to the square root of S times S minus A times S minus B times S minus C, where S is equal to A plus B plus C divided by 2. Okay? So let's do the formula for example 5. Right? First, we need to find S. So S equals to A plus B plus C. So A is 43, B is 53, and C is 72. So I'll be 43 plus 53 plus 72 divided by 2. It's going to give us 168 divided by 2, which will give us 84. So S is 84. So now I need to plug everything in, right? My S is 84, and I already got my A, which is 43. My B is 53, and my C is 72. Right, so it will give us 84 times 41, because 84 minus 43 is 41, times 31, because 84 minus 53 is 31, times 12, because 84 minus 72 is 12. We put into the calculator how it is, and we get the square root of, what is it? 12, let's see here. It's going to be 1,281,168. So the square root of that will give us approximately 1,131.8869 by 69 meters. Round it off to the nearest meter, I think, or to two places. The area will be 1,131.89 square meters. See, guys, here I put the square meters, guys. That's the way it should have been on the previous ones that I did. But the answer is 1,131.89 square meters. And I believe that's the workshop for today. I think I finished it like early, but that was all that was important, guys, for these two sections. Okay, let me go back to the host so they can inform you about other things to come.